Hey guys, um, let's give these other guys a little time to join. Yeah, we'll start in about 5 or 10 minutes. In the meanwhile, just have a conversation, or if you have any general questions, you can ask me. Anything else that you want to discuss, it's fine. Let me try and think about what we were going to talk about today. I mean, obviously, we can play it by ear. What were we doing last class? Last class, did we leave stuff in some intermediate state that needs to be wrapped up today, or are we done with last class? Whatever we did last class, I forget, because we've been doing a couple of different things, right? So someone refresh my memory, okay? At some point, I haven't got my chat window.
I think I tried to answer that question.
Yeah.
And you were doing that as well. Why calling a function takes longer than inlining it.
Oh yeah, I saw your post. You mean in the subreddit?
Do you think I was correct?
Yeah, very nice. Yeah, thank you for making that post. But it looks like you're the only one who. So yeah, all right. So not Chad, okay? Not Chad. Who was Chad? You weren't typing. Were you typing last class? No,
nope.
I think Peter or who was typing last class? I forget.
I think it was Peter.
Yeah, I think it was Peter. He's not here. Yeah, what were we coding last class? We were coding. Oh yeah, I remember now. I think we were doing Fibonacci, right? Fibonacci, and then iterative, and yeah, we can talk about recursion today a little bit. I don't want to waste too much time on it because it's already straightforward. And then now, there's no amount of talking about recursion is going to help. Okay, so you gotta be bitten. You gotta be bitten by the recursion bugs. And you have to be very unlucky if you just if you didn't encounter any of the recursion monsters, right? So you have to meet each of these demons and defeat them, like the little bosses before you get to the big boss, right? So the Ganondorf is out there, but not conquer in the sense you need to be familiar, right? You need to know these demons, and that they will bite you, but they're not going to kill you, right? And the bite is not going to be it's not, you'll forget about it in a little while. So but if you're aware of that, I think that's the thing that I find with many of the beginning programmers. Because programming, if you think about it, everybody, all humans, right? Yeah, it's just logic, right? Just codified logic, and we've been doing that ever since we were born, really. As soon as we get the ability of critical thinking, right? And I think, why is it that lots of people don't take it up? Well, why is this intimidation factor? And I was talking to, I think, one of you yesterday too, and I came up with a bunch of hypotheses there. It's about partly related to humans not yet getting to the level of trusting a machine, right, more than they trust humans, which, ironically, it should be the other way around, right? So maybe I think for beginners, it's very hard to get into the mindset of being able to trust a machine to do what it's told, right? And so they needlessly worry about lots of things that they don't have to worry about, which does not free up their mind to think about what really needs to be worried about, just like in real life. Yeah. So, in real life, we there is something that we need to do to make us happy, but we never ever do that because we spend our entire time worrying about useless shit that is never ever going to make us happy, right? Or we think it's going to make us happy, but we always keep going there, and that point also keeps moving forward like a carrot attached to a string, right? Or the end of a stick. We just keep following that, and the sooner we realize that, the better. And it's just like that in programming. So and I think that people just don't let go, right? If you're a control freak, saying that everything that needs to happen, I need to mediate that, I need to control that, I need to know exactly what needs to happen there. I'm not going to trust the computer to do the thing, right? Look at that, right? It's a ridiculous statement to make, is that, I'm not going to trust the computer to do its thing. No, we can trust ourselves not to do our thing in telling the computer what to do, but the computer will always do what it's told to do, right? So in other words, saying that I don't trust the computer is really an indirect way, a euphemism, right? A euphemism of saying I don't trust myself. right? If I don't trust the computer, all I'm saying is really, I don't trust myself, because I'm the one who told the computer what to do. So you got to get over that. You got to get over that, I think, and it takes a lot of time to get into the hang of using a computer as though it's just another part of your body, and, you know, learning to trust it, right? Learning to trust, you know, like all the painters do, you know, trust your brush and trust your hand. And most of the time, right, when I try and paint when I was a kid, even now, right, I make mistakes when I don't trust myself, right? When I just do the strokes, it comes to me. But when I say I need to do a perfect stroke, there's a lot of jiggle in it, right? So so trust. So that is one thing. The other thing that I find that beginning programmers get stuck at, or you know, the reason why lots of people don't get into programming. Damn, I had this really wonderful point to make, but I forgot because I was talking so much about this damn trust thing. Well, if it comes to me later, I will tell you. But there is this other thing that really is, I think, one of the really strong factors keeping people away from programming, or trying things out. It's not just fear of failure, right? I don't know. Anyway, computer science. Yeah, you learn by doing. Yeah. Fear. Yeah, that's right. Yeah. I remember now, right? So you're talking about demons and all, right? So the other thing I think that is keeping a lot of really budding young computer scientists from getting out there and shining, right? So they're afraid. And the reason we're afraid, again, just like in real life, is that we think that when we encounter a bug, it's going to kill us, right? So every little thing out there, we are so dreadfully afraid to try because we think it's going to cause a bug, it'll crash the program, I don't know what's going on, and something horrible is going to happen, right? So almost like you're going to think the computer is going to melt down because you misplaced an if statement, right? So and so people are very afraid to encounter these situations, which really, if you think about it, are fictitious, right? If I misplace an if statement, the computer is not going to melt down. Right now, you know, right? You know this. But when you're starting out to program, and think about it, right? Now you're already past that stage, but you can think about a stage when you were starting out to program, like a little kid, right? And do something wrong and some red lines or your screen blinks, then, you know, you could probably think the computer's going to crash or burst or, you know, explode.
Yes, that's actually not true. I know this.
You know this, right? But, you know, early on, I think we are stuck by fear, saying that little things we do could cause something really, really bad.
Yeah, and like, you know, the key thing is, you know, yeah, I think I remember when I saw Fatal Error a while back, I think I used to think it could crash computer, but now I know.
Especially C++ is notorious, right? Because, you know, at least other languages, the error messages you get back from the compiler, I kind of toned down a little bit, right? The C++, basically one small error, and it'll just shoot a load of bullshit at you, right? You got to really try hard to interpret what the compiler is trying to tell you, and it might be buried in there, like, you know, 50 lines out there, you know, with angle brackets and all funny looking characters, and in there is a misplaced pointer assignment or some crazy shit like that, and then again a lot of rubbish, right? So you got it, but it's not like that, you know. Once you get into the hang of it, you know exactly what to look for. Yeah?
It's normal to get errors sometimes, right, when you code.
Yeah, it is. It's very normal. But the problem is, I think we tend to blow it out of proportion, and beginners tend to blow it out of proportion more than experienced people. Yeah, and again, I used to say, when you're stuck with something in binary, think back to decimal, because, you know, you're used to it and you can relate to it. Just like that, you know, you're stuck in something in programming, think back to real life. Right? Because, you know, there's almost a one-to-one map, and we always blow things out of proportion. We think that little things are going to cause these incredibly, you know, huge failures. So we stay away from it altogether. So because we stay away from that, there is actually an imaginary demon there. There is an imaginary demon that, because that demon does not really exist, right? It's a demon that's going to melt your computer, and that demon will surface as soon as you misplace an if statement. Right? But that demon is just imaginary, because, you know, or an experienced programmer knows that just by misplacing an if statement, that demon is not going to come and mysteriously evaporate your computer, right? But someone who hasn't tried it, not experienced, right? A novice, right? They would think that demon's still there, is still there. So that demon really is just Maya, right? It's just there. It doesn't really exist. And the reason you are afraid to go in that direction is because you think that demon is there, right? So I think the way to become a successful programmer is to basically say, I'm going to try it all out in the safety and try and use my intelligence to identify as many of those places as possible where I think there are demons, right? But they're not demons really. So I can safely navigate just with a little bit of care. I can navigate and I get to my success. And that's the reason. So number 2 reason I think why people don't experiment. Right, young people, right? Maybe not you guys, right? So maybe when you were just starting out programming, or maybe even now in C++, right? So even slightly experienced programmers coming to C++, right? So they don't experiment as much as I hope they would. Is primarily because they're intimidated by C++, and then the volume of errors that you see just throws you off kilter. And you think that, oh my gosh, I did something dreadfully wrong and my computer is going to crash, and maybe my compiler setup is all screwed up and I can never again compile another C. Because I used to think that, right? So the first time I tried something and, and then I thought, well, I went through so much trouble trying to get this compiler installed just right, like VS Code, or, it was actually Visual Studio, I think, right? Installed just right. And I just compiled this program and I had to do something to make it work. And then it created a bigger problem. Now, because of that change, I just ruined my compiler setup. I got to waste like 3 hours to set up the compiler from scratch, delete it. And how many of you have gone through that, right? So, but once you've done that a few times, what you've broken. And so I think it's important to encounter these demons, right? Encounter these demons and know that they're not really demons, right? They're just around to help you most of the time, right? So these demons are out there to just say, hey, I'm not going to kill you, but, but this is a bad idea. Don't do that, right? So these warnings. But once you know they're friendly demons, you're not going to be afraid of them, right? So in the beginning, you think they are scary demons. They're out to get you and your computer. Right, so we're afraid, and so you overcome those 2 things, and I think the only way to overcome those 2 is to familiarize yourself, right? I think that there's no amount of you can't I can't tell you that demon is actually a friendly demon, that demon's a friendly. I can't tell you all that because in your imagination they're just stories that I told you because you haven't encountered them, right? So, and in your mind they're just fierce beings right out there, out to get you. So the only way you can be disabused of that false notion is to go out there and try it out, right? In the safety of this class, maybe, when, all these experienced people and we're all out there watching over you, you can come out and try it out. And all right, okay, well, I used to think they're demons. They're not so bad after all, right? So they're not the Ganondorfs that I thought they would be, And those who played Zelda, that even Ganondorf can ultimately be conquered, right? Yeah. Okay. All right. Great. What is it now? All right. 8:15. All right. The promised time has arrived. So we should be starting to talk about class. And yeah, we have a decent number of participants. Not all of you show up on screen for whatever reason. All right. Okay. So, well, maybe I haven't got my chat window open. Oh yeah, Ben actually has a question. We're done with the main portion of the lecture. May I suggest a quick review on? Great, yes, thank you. Hey, Ben, yes, so Ben has a suggestion. I'm perfectly happy with that. In fact, what I would like is you guys should chime in and say yes under the comment in chat that Ben made. Say yes if you want it. Now, if that works, if you guys want it, here's what I would do, right? Now, the 4 or 5 students who've been on screen before, they're not going to participate, and I'm going to step away. I'm going to switch off my video, so I'm not here. You don't have to feel encumbered by my presence. But, I'll be around. So if you want me to come back, I'll be around there, behind the computer, or, next door, maybe, just next door. Yeah, I just need to check something in the workshop. Let's just call out, right? Just call out really loud, hey, on, and come back, and I'll come back, okay? So I'll be there, let's say about, I don't know, half hour or 1 hour. And then we can come back and I can talk about stacks. What is it, Tuesday? Yeah, Thursday. Yeah, Thursday we can implement a stack. We can implement a stack using linked list. And I'll also talk about stacks. So we actually have a whole class. This is week 10. Week 11, next week, is all about pointers and nodes and linked lists, okay? Especially important for those of you who haven't done quest number 9, yeah? Because quest 9 is when you first encounter pointers in your life as of a C++ programmer, right? Up to quest 9, correct me if I'm wrong, there are no pointers, right? Anyone who's done quest 9, correct me. Are there any pointers at all until you hit quest 9? Elephant, a stack is done using arrays. I can hear any of you, by the way.
Yeah, I think there were pointers, right?
Oh, yeah, yes.
Where do you find pointers?
I think even in Quest 8, which I am currently working on right now, there were pointers.
Yeah?
Yeah.
No, I thought there were references in Quest 8. The pop val, you mean?
Well, in Quest 8, it was all about stacks.
Yeah, and it was stacks using arrays, right?
Yeah.
Why would you use pointers there? I'm not sure why you'd use pointers there.
Well, that might be quest 9, actually, right?
Yeah, so that's what I thought. Quest 9 is when you first get introduced to this whole idea of pointers. You don't need pointers until quest 9. And if I'm mistaken, you should let me know, because
my bad. I mixed up references for pointers.
Yeah. That's what I thought. That's why, because the ampersand is the address off, and you might have thought, oh, okay, there's an address off that's a pointer. Yeah. Yeah. Okay. So yeah, but if you do encounter a pointer before quest 9, maybe, I don't know, quest 5. Oh, look at that! It actually, now Apple actually says it's a telemarketer. Can you see my screen? I don't know if you can see my screen, but it actually says telemarketer. Yeah.
See, nice.
It's really cool. Anyway, so but the funny thing is, it's actually telling me it's a telemarketer, right? Instead of automatically muting it and canceling it or playing a recorded message, which means it's telling me, hey, I got a telemarketer if you want to talk to one, right? That's basically what it's telling me, right? It's giving me the option of talking to a telemarketer. Okay, all right. So what were we talking about? But I think if you do tell me there's a pointer somewhere in an earlier quest, it should be easy for me to get rid of it, right? Because it should have been a mistake. It should really not even make its appearance until quest number 9. And quest 9, and I bet, hang on, quest 9, and then let's see, 2B, quest 1, 2, 3, no pointers in 2B quest 3, 4 pointers, 5, no pointers, 6, virtual functions pointers maybe, yeah. And 7, yeah, okay, yeah. But you pretty much, pointers will become your staple. After you finish quest 9, after you finish the platypus, right? I think pointers would be your staple, right? Everything else becomes flavoring now, right? And hopefully you don't have spaghetti for your code, right? So you have pasta and pointers. So here's how it'll go. Right, so you guys, I'll be out of here. I'll switch off the video, and then one of you should take the screen, and hopefully it is not one of those 5 people, right? In fact, well, it is the 5 people at the bottom of my screen and at the top left chat, okay? Not you guys, or Robert, right? So it should basically be someone who is not, well, I don't know, it'll be hard to enforce, but really it should be geared towards the people who haven't yet, got comfortable enough with loops, okay? So what you're going to do is essentially open up a replete window, share it with all of you guys, right? And and each of you take a function, right? Maybe call it Chad function and Matthew function and Ben function, Tina function, right? And each of you is basically coding into your function, and you have a main at the bottom, right? In the main, you can call any of your functions and run it and see the output. And then after you're done, you can comment it out. So someone else can basically run their function and see the output and comment it out. And you can also comment on each other's code. Does that sound like a good plan? Yeah?
Yeah.
All right, so one replete window where you're all coding in different sections. And in your main, at any time, you can basically call your function and see its output. And then you can also say, hey, Robert, in your function, you have a loop, right? And now in this function, you're not allowed to do anything more than looping, okay? So no pointers, no nothing, all right? Just looping. And try very simple loops and different ways of switching loop variables around, maybe do while, No, forget about do while, right? Just get comfortable with for. Okay, for I think for is a most straightforward loop, right? I showed you last time, right? We did the function 2 different ways using for loops, and then also we try to do it using while loops. But when you use a while loop, the exit condition and everything is not so immediately apparent. You see the value of the for loop there, right? It's complexity wise, they're both the same, but the value of the for loop is that it is immediately obvious exactly what the end conditions are. There's very little corner cases you need to figure out, but the while loop is not so much like that, right? Because the corner cases might be hidden and you don't know when the increment's happening, when the test is happening. It's a little bit more messy, you know? So while usually is more suited for situations where you don't have a counter, but you have a condition, like while you're not yet done, right? While not all nodes in the graph have been visited or something like that, right? So you have a condition, then you use a while loop. For a for, you would use it when you have a counter that many times. And then it reads a lot easier. And you have a live example, right? Last class, we actually did that in a while loop, and then we didn't manage to complete it, right? We just said, yeah, all right, so there's a condition, the corner case here, it's not going to meet it. You need to fiddle with it, right? So yeah, those things you can work on. You can work on those. Do it slowly, step by step. The only thing you have to do is anyone have any question at all, no matter how basic, right? Someone has to answer it, okay? So don't let anyone be stuck, okay? So you should feel free to just interrupt anyone and talk. Now it's 8:23. How about until 9:15? How about 9:50? So you have 45 minutes of basically playtime, yeah?
For loops.
And by the way, if people aren't playing ball, you should just feel free to message me or talk to me, or just call out my name. All right, I'll come back and say, hey guys, slow down a bit or something like that. Okay. So is that okay, guys? Are you guys okay? Yeah, and it'll be recorded too, right? Yeah, it's automatically recorded, so you should be able to. I'm going to mute myself now and then go stop the video, and then I'll step out of here. Okay. All right. Thanks.
Hi, can everyone hear me?
Yeah.
Yep.
So yeah, please let's get to the link that I just shared. Anyone has an idea of what to play with a for loop?
I'm not too interested in for loops, so I'll leave it to you guys. Like the structure is simple enough. One sort of interesting thing you might not know is you can leave out some of the parts of the loop. Like in the head, you like I equals, you can skip some of those I equals, I less than, I plus plus. You don't need to include those in the loop, like header or whatever it's called, but I feel like I'm familiar enough with them that I'm not too enthusiastic about practicing on them further. So I'll leave it to you guys.
Thank you, Matthew.
What did you say about if statements?
Oh, no, it's just for the for loops. You know how you can do, you start with, I don't know, I guess I'll type it. How is it? Yeah, for example, with Chad's one, it has size. I don't know, I guess I'll make my own section. You have like size I equals 0, I is less than 10, I plus plus is the usual syntax for a for loop. And you can remove some of those parts. Like you could remove I plus plus from there and it'll still function. you should probably throw I++ somewhere inside the loop if you're not going to include it at the top. But you don't need to include all 3 parts of the.
I'm trying a for loop with
loop.
floats.
Yeah.
Yeah.
You see that? Seeing what it does.
Well, yeah, a for loop's pretty simple because it's like a while loop, but it's in a for syntax. It's just a different syntax for a while loop. So it's, I don't know, there's no real trick to it. It's just a simple way of repeating an operation a couple times. Yeah.
Well, I know nothing about pointers. If someone wants to try and explain that to me.
Hey guys, I mean, it sounds like nothing is happening. So I came back to check, and what's going on? There's no screen, and there's
I'm
nobody.
trying something interesting.
Yeah.
Well,
Can I
I
share
asked-
screen?
Is each one doing something interesting on their own? Is that how it's working?
Yeah.
So why do we need to come to class then?
It's a good question. I asked if anybody needed.
Right.
Has
So
anybody else
yeah.
work
No,
on it?
so sometimes people also won't explicitly ask, right? So you got to see when other people's cursors aren't moving, and then say, hey, are you stuck? Do you need any help? What's going on? Right. And then you may say, well, each one of us is coding up our own function, right? Like Tina function or Robert function and chat function and
Yeah, I'm trying a for loop with numbers.
Yeah, it doesn't matter. Each one, you try a for loop, maybe you calculate factorial, someone does, something else, Fibonacci for for loops, someone tries a different kind of for loop, all right? Without a condition, all semicolons, infinite for loop, so many variations, right? So many, it's like a garden of flowers. So you got to explore these things. So each one tries these things in their own function, right? So that at any time, one of you can go to main and basically call your function, see the output, and then get rid of your call. So someone else can go and try out their main also, and so on and so forth, right? But each one is working in their own function. But at the same time, you're also every 10 seconds or so, you're going to look at all these other people, right? And say, hey, are you stuck? What do you need? And also people who don't know, right? If you suppose you're trying to complete something and you're stuck, you don't know what to do, you got to pipe up and ask, right? Even I'm not there. You're amongst your own friends and classmates, right? So you should say, hey guys, I'm basically stuck here. What do I do? Right? So you should be able to ask. You should be able to ask, and then someone will, I'm sure, will be able to say, hey, where are you at? What are you trying to do? Right? And once you know what you're trying to do, Oh, Ben just shared a screen. Like that, right? So Ben's cursor. Oh, I see. You only see one cursor? No, I actually do see other cursors. I see a green cursor. I don't know if that's not. I don't know. It's not blinking. But anyway, you should be. Yeah, this is a red cursor, and I see these other cursors too, right? And blue, right? So yeah, all you guys are there. But you should basically, at any time, you should ask, look at these other functions, right? For example, Peter might look at Ben's function called Ben loop, and say, hey, Ben, it looks good, but I think your for loop needs to be indented in slightly so that it looks better and so on, right? So help each other, and I think it'll be a lot better. And by the way, if you want to call out to me, right, this time I basically lucked out because I came back, there's no sound at all and nobody's talking. So I came back to see what the hell is going on. And then I noticed that, there's no screen and this is just, all these icons of people, even photos, right? I don't even know if you guys are there, and silence. And then I saw Ben's message saying, hey, can you help out, right? But if I'm not here and you guys are not vocal and calling me by voice, how could I hear you, right? It's and you got to be talking to each other too, right? So I'm going to take off now. You still got time. What time is it now? What time is it now? Yeah, you still got time until 9:15, right? So, but I want to hear you guys having a rich discussion and helping each other out, right? And if someone is stuck, you should help out, right? Say, hey, try this, and maybe generate some ideas. If you say I don't have any ideas, then that's I'm really sorry for you, right? No, you should come up with ideas, right? So just 4, even if you only have to do 4, there's different ways in which you can use 4, right? With an infinite loop, no condition, no assignment, no increment, right? The increment happens inside the body. All these, there's so many different experiments you can try and do these things. And with each experiment, you can do something interesting too, right? So increment before, after, print something, calculate a value, calculate a tan X or, so many things, pick up the, Euler series, not Euler series, it's a Taylor series expansion for some function that you like, right? And calculate that using a loop. All these things, you can try all these things. Okay, so is it okay? Can I step away now? Right? Obviously, I want to keep talking. Right? I want to keep talking, and I want to keep guiding you through the code. But I'm getting some feedback from you too, right? And I don't think it. I think it needs some mix of input from you guys also. And not just me talking all the time, right? So you guys have to talk, to code and practice coding together, because that's what you're going to be doing later on in your life, right? In your life, you're going to be working with some other people, and you have colleagues and fellow programmers from other cubicles, and they all come get together and talk over lunch and dinner and over a computer, right? So that's what you're going to do. If you can't do it now, how are you going to do it now? This is your practice for all of that, right? So you got to. Tue is not just practice for learning C++, right? It's for learning to program using C++, which means you need to know how to work with other people, right? Together, bounce ideas, right? Also be able to adapt at looking at someone else's code and saying, hey, isn't there something wrong there, right? You need to be able to spot an issue with their code, which they may not be able to, which is very, very common, right? You won't be able to spot issues with your code. Someone else might be able to, right? So you got to get good at that. You got to get comfortable enough to look at other people's code and say, well, it's time I start looking at other people's code too, not just my own, right? So all those things, they're all part and parcel of becoming a good programmer. So you got until 9:15. So I'm going to mute myself again. And you guys need to talk to each other, right? Help each other out. Have a fun banter going here, okay? And program together. And this is your chance to experiment as much as possible. All right? Is that okay? Can I step away? You can call me. You can call me.
By the way, Ben, what exactly did you need help with in for loops? Ben?
Yes, I'm here. Thanks for asking. I can also suggest that if the better help is needed for pointers, and somebody who knows about it can talk about it too.
No, certainly not. Say, hey, Ben, if someone started talking about pointers, are you confident you can follow along?
Might not be.
So what are you doing? Are you like sacrificing, saying, hey, I am sacrificing my class time today so you guys can have a better life?
No, just tell me what you needed help with in for loops, and I'll try to help you out.
Let's see. I mean, I don't think I have enough practice. I've done some for loops, and
okay, so let's try to think of an actual exercise with for loops.
Sure, please. That'd be nice.
All right, so let me think.
Thank you.
I guess we could
Fibonacci. It's a classic.
Yeah.
Sure.
Okay, we can do Fibonacci. We can do Fibonacci with for loops. That actually sounds like a good idea. Well, we had code for that, I think, last week, or was that the week before? I'm not sure.
Last week.
Past week.
Okay, yeah, cool.
And I think I remember I did something like that on one of my quests, but I can't show it to you.
And do you understand? Do you know what each part of the for loop does? Like int I equals 0,
Yes.
I is less than 10.
Yes.
No.
Yes.
Oh, okay, good.
Yeah, I know. I understand for loops very well.
Yeah.
So I just,
I'm pretty sure
you saw that creative float loop I did.
Oh yeah. Yeah. Okay. Well, that's probably just a matter of practice. Never hurts.
Yeah.
Good.
Anyone would like to walk me through a Fibonacci for loop?
I was actually wondering something.
Wait, hold on, Chad. Okay, so, well, all right. Hold on.
Can I walk through it?
Oh, okay, sure.
What should be the type for the function?
Well, I'm pretty sure int, yeah.
If we'd follow the usual, I actually forget how the Fibonacci thing works, but you could create a vector and then create a vector the size of the Fibonacci number index you want to find. And then you, for each item in the Fibonacci sequence, you calculate it in the vector, and then you turn the, I didn't explain it well, but the code we used last time should work. We'd pass in integer, I assume.
I'm kind of looking at what Chad is doing, so.
Chad, you should definitely explain what you're doing as you're doing it.
So I'm doing some of the special cases of Fibonacci, which, 0, 1 and 2 are always
1, 1, right?
1. So that's why I'm returning hard-coded values for these.
It's like
Oh, sorry. It just maybe when you get to the for loop part, so you might already be on the for loop part because the screen has some delay. But let Ben do the for loop.
Yeah, that'd be cool.
Because he may have trouble.
I think we should let Ben do it. Ben, why don't you take over?
Sure. Yeah, can you take over? I got the for loop.
Sure.
I mean,
0 return 0, 1 return 1. 0 meaning there's no terms in the sequence, so there's nothing.
No, I'm pretty sure that's the index of the sequence. So the 0th number of Fibonacci is 0.
It is?
Yeah, so
Yeah.
0, 1, 1, 2.
It start with 0?
3,
I thought it started
5.
with 1.
It starts with 0 apparently.
Oh, I see. Perfect.
Yeah.
So the 0th is 0, 1, 1, and then the second number in the sequence is 1. And what happens after is a for loop. Correct. And what is the first? I guess I should do a size t.
It doesn't need to be size t. It could be int, but
I don't.
Oh yeah, no. It actually has to be size t because of index. Yes, size t.
Because here it's
yeah. Yep.
And what does size t? What is the difference between a size t to an int?
So a
size t can only be positive.
Is unsigned.
So non-negative.
Yes.
Can it be 0?
Yeah.
Yes.
I think I did 1.
I see. Cool. Size t I equals 0. Semicolon, and then I smaller than, I guess, index.
Yes. By the way,
yes,
you probably do not want to start at I is equal to 0 because you've already dealt with a few cases beforehand. I'm pretty sure you have to start at 2, or I'm not sure, 1 or 2.
I think you could start at 0, but or
2.
I don't know.
Oh no, definitely not 3. Yeah, 2. Either 2 or we'll see.
Yeah, we'll see how many it outputs, and then we adjust by 1. That's how I think about it. And then each iteration we do I plus plus. Is there a difference between plus plus I in this?
Not in this context.
Not in this context?
No.
Mm-hmm.
That was my confusion for the for loop. Bracket, and then we do the iteration num1, num2. What is temp now? Meaning the third number?
Yeah.
Yes.
You can change the numbers in code because it's your function. So if something doesn't make sense to you, feel free to mess with it.
I think it makes sense. Yeah.
I think one of those numbers like num1 or num2 should be 1 because Fibonacci has a 1 in there. I'm not sure. You can figure it out.
And then what we want is to, in the end, we call the function at the very bottom in the main function that, we write Fibonacci, and then in there we say, the 7th term, and then it's going to return me.
Yeah, the 7th term
after the 7th iteration.
Can I write this part in the for loop?
You can show an example. Hope I'll try to understand. Thank you.
So first of all, I add the first number and the second number to the temporary number.
Chad, to be fair, that is the rest of Fibonacci. I really do think you should let Ben do this if he wants.
Cool, I'll do that. I actually made the second number 1 for my code. And
Ben, do you want to finish up the Fibonacci?
I'd like to be guided to walk through it if possible. And Chad can help too.
Ben, do you know how the Fibonacci, like what the sequence is? Like how
I think
it works?
So.
Okay.
Hey, Chad, how about this? How about you tell Ben exactly what you were going
Yes,
to do,
please,
and
Chad.
yes, and guide
And
him
I'll
through
type it. I appreciate it.
So I can type it.
You can
just
tell
talk
me, and
it
then I'll
out.
type it.
Yes.
So first I
Thank you.
add the two numbers, number 1 and number 2, to the temporary number.
Logic to the temp. In this case, it would be, you have it. Temp num equals num1 plus num2.
And then you set num1 equal to num2.
Oh, we shift everything to the left, kind of.
Yeah, that's what we're doing.
And then when equal, do I do double equal, or is there a difference?
Double equals checks and equals sets.
Pardon?
Double equals would check if something is true. So
I see.
if
Then number 2
equals
equals
one,
temporary number.
yeah. So it's
You
a
mean
single equal.
Yes, the new number that we had from here is now the old number, kind of. Number 2.
Yeah, as we're shifting, you know?
Yes. So temp, oh wait, num2 equals, when, I guess, being not as experienced, when I see this, I always think about the other way around. Instead of, okay, the value of num2 is now back into the value of num1. Num2 is temp.
See, we're kind of shifting it.
Yeah, I see it now.
Yeah,
And then
after
I
that,
think
you should return
see,
this number 2, because that's also that.
inside the for loop?
No, outside the for loop.
No, it's outside, right?
So
Yeah.
outside of the for loop.
Or it will,
number 2.
if I do it inside the for loop, would it see out a sequence?
Well, you could try
Try to
it.
play with it. Okay, yeah. It's getting more fun. Thanks, guys.
And if you did a return inside the for loop, do you know what it would do? Like if you put the return temp num inside the for loop, you know, do you know what would result in? Or you could try it, yeah.
Sure, let's try the one that you suggested. Return num2. Well, but then wouldn't it just stop the iteration?
Yeah, it would.
It would.
It would.
It's always good to know what it'll do.
Another question, are we doing a sequence or are we doing, or are we returning that specific number index?
Let's do is a specific number first, and then let's return a sequence.
Cool.
How about
so I know what to do. You should put the return outside of the for loop.
Well, thank you. Yes, exactly.
Another way to break a for loop, if you don't want to return anything, is to literally type break, and it will break the for loop. So in case you didn't know that, it's pretty helpful.
I don't think you should break it here.
You don't need to. I'm just saying that
when I put return, let's say num2, which is that number that we want, what does it give? Does it see out in the end this number, or do I have to see out it?
Yeah, I'd have to call C out because
I see.
That's what. Yeah.
Thank you.
Well, you can also.
No, you can also do C out that function.
Yeah.
You don't need to do this.
Pardon?
You don't need to see out num2.
You don't need to
just see out the function.
Yeah, outside the function.
At the bottom?
Yeah, precisely. Inside main, you still need to call your Fibonacci function. So
sure. Yeah. And maybe I'll delete these. I should make these.
Or just comment them out.
Yes. What was the name that we had for the Fibonacci? Okay. Oh wait, that's the wrong one.
You need to see out.
Yes, thank you.
I mean that if you want to see the output, you know.
I do, yeah.
Yeah.
Oh, don't. that's these are arguments. Change it to don't say size t.
Just do the number, right?
Yeah.
Thank you. Because it already knows what this type is.
Don't do 1 or 2.
Yeah.
Maybe 3.
Let's do
yeah,
5.
anything like that. Any positive number.
Sure. Okay, let's run it. And then we do the sequence. I really appreciate, everyone's engagement.
That plus loop, you need to put a dummy. You need dummy it. So
where is it?
Yeah, it's on line 32.
32.
I dummied it.
32.
It's just someone else's bad function.
Sure. And also you're forgetting a semicolon on this last line.
It looks fine.
Where is it?
I'm not sure.
Okay, let's run it.
No. Oh, there we go.
Is someone else is also running this? Yeah, I'm not so sure. Let me. I'm gonna try to comment out everything here.
We're commenting it out.
I just did.
Got it. I thought you were commenting out all the code for a sec, but didn't update.
Did it work?
Weird.
It does work properly.
Yeah,
I mean,
yes,
the index.
Yes. It works.
It works?
Yeah.
Oh, because you put
try
3.
with a different number. Try try with multiple numbers.
Chad, you want to put like 7 or something?
Yeah. The index 5 is actually technically 5, if I'm correct.
Yeah. Hey, this workflow, I know some of you probably know this already, but it was very helpful that, all of you walked me through it, and I have better understanding of it now. So thanks to you guys.
Yeah, of course.
And then,
hey Ben, I think there's a couple issues that I saw earlier.
Sure.
While you're coding, you asked some interesting question like, what's the difference between equal, double equal? I think, do you need to some clarification on that?
I do.
Yeah.
Okay, so the difference between double equal and a regular equal, a regular, like only one equal sign, like for instance, how you did size t I is equal to 0, that only assigns a variable to a value. So you assigned I to 1. However, a double equals sign, that's just a check. So it's like if index is equal to 1, then return 1. Basically, double equals is a check that will return true or false.
Boolean?
Yes, a Boolean. And a single equal assigns a value to a variable.
Yeah.
Thank you. Super helpful. And so we had it right. Okay. And then we, instead of just returning one number, we do the sequence. So
by the way, you can it doesn't, the indentation doesn't really matter, but on the return statement, you can indent it backwards by 1.
What is in this?
Yeah, exactly.
Just looks nicer.
Really? Is there like a very standard way of where things should be put?
Yeah.
Okay. Okay, we just
usually so Ben, I think the answer to that question is usually you there's really, there's a lot of standards in terms of how do you indent your code, but usually you want to make it so that it looks like the return statement is at the same level as the for loop. All right. I
see it now.
And the reason why is because if you look at the for loop, the stuff that's inside the for loop is indented to the right, like your temp, your num1, num2, cout. Those three, four statements are indented to the right. And the reason why we indented to the right is that it looks like it belongs to the inside of the for loop.
Perfect.
And then once you get out of the for loop, the return statement is at the same level as the for statement. And so that's why we dedented to the left. Yeah. So it's a way for programmers to see, that these codes are executed at the same level, or they're one after the other. I don't know how to explain it, but yeah. So yeah, it's you do want to indent it properly so you can see the code better. Yeah, but it's not necessary for C++.
And who is this talking?
Oh, it's Robert.
Robert, thank you. Yeah. Okay, we have, and what do we do for return? Since now we have a sequence.
Well,
we don't have a sequence yet. We got to put together.
Yeah. So the question you should be asking is, what do we want to return? Like you call this function. Yeah. Let's say you just created a function called Fibonacci, right? Or actually Chat created it. And the input to this function is an index number, right? And what do you want to be returned from this function? I'm asking you, what do you like? What would you like?
A sequence from the first number in the Fibonacci till the number that we put in.
Okay. So that's a good answer, all right? At least we know what you want. What Chat wanted was, let's say you have a Fibonacci sequence of 1, 1, 2, 3, whatever the sequence is. Chat is just returning one number. Okay, so that's what Chat had intended. And if you, how do we know? We just take a look at the first line 63.
Can I work on the second part, printing? I think I know how to do this.
Wait, Chat, hang on a second.
Hold up.
Let Ben understand this part first.
Let me breathe.
Yeah, so if you look at line 63, can you see it? Yeah, and by looking at line 63, we have an idea of what Chat had intended. And the reason is we look at the first three characters, int. That tells us what it's going to return, the function Fibonacci. And it's returning one number. All right. So we cannot, based on the definition for this function, we cannot return a whole sequence of numbers. All right. That makes sense?
Yes.
Okay. Yeah, somebody changed it to 0, return 0.
I did.
Oh,
I just did.
Okay. Yeah, so if you want to return a whole entire sequence of Fibonacci, then most likely you want to pass in like an extra variable inside the parentheses, like right here. Let me just hide it.
Where?
Right here. If you right in this area. Okay. Usually, if we want to, let's say, get the whole entire sequence out, then you want to pass an extra parameter. Maybe after index, you want to pass in.
Oh, I see.
Like a vector. But I don't think we should go there because it gets kind of messy at your stage. So
sure.
Yeah, let's just stick with what Chat had intended, which is you have a sequence of Fibonacci sequence, like it starts with 1, 1, 2, 3, 5.
I actually know how to make it so 0.
And what Chat is asking is, hey, given that I want index 4, I want to return 3, and that's what this function is supposed to do.
Yeah.
So I have something to tell you.
Sure, please. I'd love to.
So I know how to make it print without putting it in a list.
Without putting in the, well, isn't that what we're doing? CL1 for every iteration?
Yeah. So give me a sec.
Sure.
So first of all, you make the size t 0, the index 0, and then you add an if statement at the beginning.
Wait. Is that necessary?
mean, you know, if you want to print it with 0 included, the sequence.
I don't think it's really necessary to print out, but I just Google the Fibonacci sequence if I wanted to know.
I mean, it's nice.
Yeah, sure. Yeah, if you like that sort of thing.
I wonder if I'm still seeing the lag. Is chat down with the typing? Oh,
Not quite.
sure. Now you have the double equal, checking whether the value is true or false. I mean, in this case, this is true, so. I'll continue. Are you done, Chad?
Yeah.
Okay.
We need to
Should we
debug
run
this.
it? Is it problem already? Oh wait, we only have like 2 sequence. 2, so 0, 1, 2, so we have 3. Seems, why 0, 0? Is it because return 0 in the end?
It seems to kind of be reversing. Oh yeah, I think it is return 0.
Well, it's because you made a couple errors in the code. I'll fix it. You don't want to see out num2 because num2 is 1. You want to do num1 or just I. You're in that line 68 through 71. You're basically printing 0. You don't even need inside the loop necessarily. And then after that, what is it that you want?
Sorry, you're kind of fast. And
sorry.
My brain is a little, yeah.
Right. If we want to print out all the items of the Fibonacci sequence up until the index, which is given by us, which is probably like 5 or something. First, we want to check if 0 is in that sequence, which is what line 68 through 71 does. And then we print out all the, inside the loop, we want to print out all the other ones, which is what we do at line 76, all the other indexes up to our index. So.
Oh, I forgot something.
Actually, this might work. I don't know.
Give me a sec.
Yeah,
I think you might need to make the other C out. You might need to make that one num1 as well.
Yeah, I need to check to see if it's equal 1 as well. I think it should be correct.
Right. Yeah, our loop actually starts at 2, so we need to deal with 0 and 1 separately. Or our loop used to start at 2. Yeah.
Oh, there you go.
And don't return 0. I think it should be void.
How do you change that into a void?
Just
that's
just
it?
switch it to void. It's a variable type, but
then you remove the return event.
Yeah, and that will work.
Oh, and also you should probably remove the C out.
Where is this? Which one you're talking about?
I think the code's good. Oh, at the bottom, line 88.
So instead of doing C it out, if we do this, it will automatically write it out? Oh, because we have C out already.
Yeah.
Okay. Gotcha. Perfect. Oh, so what we did, the past minute is to get rid of the return, meaning the 0 in the end.
Yeah,
right?
we just, yep.
And then what we did was using, instead of the int, which needs a return, and we use void. But how about here, like in the end, in the main function, in the end, we still have return 0, but how come it doesn't?
C++ or programs in general should return 0.
It's weird.
Yeah, it is sort of weird. It's just to tell the
the computer that everything is okay.
Yeah, precisely.
Okay.
Because normally there's
false
an
and it's
execute
okay.
1, which means someone is wrong. Right?
Exactly.
I
So
see.
you would return 1 if something is wrong.
I see.
Yeah.
I really appreciate the walkthrough. I understand more now. So yeah.
That's good. That's great. Oh, and also I forgot, but now we should do branching statement practice.
Somebody else take over.
Maybe can I just maybe I'll just stop because
We
I've been
have
doing quite a bit. Right?
about like 12 minutes.
How about I'll try switch case?
Oh, instead of using if?
Yeah.
I
Sure.
think if would actually be more.
Or-
Do you know how to use if, Ben?
Yes, I mean, on a basic level, yes.
Okay. Well, what was your exact problem with branching statements?
I don't know enough.
I think just
Okay.
practice, which is my opinion.
Okay.
But
Yeah,
can we
just
practice? How
yes,
about
sure.
can I walk you through switch case?
Sounds great.
Sure, please.
So you first type in switch.
Let Chad do the magic. Oh, I remember there's some sort of, you have to do a break in each case or it will
Yeah.
just continue to run.
So 0.
Let me do the second case. You do the first.
I think the continue can work here. Can I just make it another function that just a switch?
Ah, I see. I think I'm just waiting for the internet to update. Meanwhile, I'll just check the stock or something.
You can also refresh it.
Should I try that?
I
Yeah.
can still. I don't think it's the internet. I don't know.
Oh wow, it was internet for sure. Yeah, cool. So we had if before. We took care of the 0 and also 1. So here we, instead of using if, we used switch.
Yeah, and you get the exact same thing.
Oh, what would happen if somebody typed in, instead of a size t, non-negative integer, they typed in some double number?
Oh, maybe
an
I'll try that.
exception.
Would the case in case 0, case 1, you know, kind of break down?
Well,
Let's see, it's between 0 and 1.
That's for the loop, remember? The size t loop, so.
we're expecting a size t for index, and you're not giving a size t, so well, you can
I
see
think it
what happens.
truncates it.
Oh, I see.
No, it doesn't.
It doesn't?
Well, you can see the exception message. That's what happens when something goes wrong.
Yeah.
So it's wrong?
Yeah, it says.
So yeah, you see here, it's changes, see right here, it actually is converting.
Well,
it's
there you
not an
go.
error, receives a warning.
I see.
all right, yeah. No.
You see, so it does work, it just truncates the number. Truncates it.
I see. What about a number
See?
smaller than 1? Yeah, I see. Yeah, that was a good catch. And then I assume that if you put 0.1,
But what the
it
heck
would
is going
become
on?
0.
Why is it kind of doing that? Stopping.
What did you put?
Oh, never mind. Never mind. It just froze. Never mind.
Okay. Cool.
See, it just does a warning.
Just a general question. do you guys find it more useful in terms of using if statement or the switch case, or
If
is
statements, in my
switch more?
opinion.
Oh, okay.
Sometimes switch case is more efficient because it won't have to like compare everything, but you know.
If it's more useful in general because you can apply it to more things.
Yeah, I like using switch case better for some reason.
I see. Well,
unless, you know, I mean, sometimes you still have to use the if statement, like for example, comparing data, right?
A question. This is, since we, you know, have a few minutes before Anand jumps back. If I wanted to do a number, like a variable that's at least, let's say 25 digits, which one should I use? Or have you, any of you have experience with like really, really large, long numbers?
I think a size T will work, right?
25 digits isn't that long, so.
Yeah, okay. I think size T or int will work.
Well, maybe. I don't know. You could try if you want to type.
Because in the end,
wait a sec.
Because in the end, sure. Because I've experienced some inf, INF, you know, numbers at the output.
That's less than 25 digits, actually, that number is. So I think use a log, right?
You could search up data types in C++ and just look for the biggest integer type.
I see.
That would probably work. I don't know off the top of my head.
Yeah, I think 25 digits is possible with any of the int or even int 64. I don't think you can get 25.
Okay. And let's see, what's something that might be relevant?
Let me see here, 10, 19. Yeah, I just did. If you do 2 to the 64, you got a number like 1.8 to the 19th power. Yeah. So that's definitely less than 25 digits. Yeah. So in 64 there. Yeah.
If you
but you could always try to, yeah, because it's an interesting question. I mean, why do you want 25 digits, first of all?
Because I'm sure it's application. I'm trying to use what I learned here in C++ to do my chem homework, which, if you remember, the Avogadro's number is 10 to the 23rd.
Ah, okay.
I would suggest I would suggest actually, like, when it gets that large, maybe saving each. I mean, this is kind of a hack, I guess. Saving each digit into like a vector of ints or something, and basically you loop through when you want to add two numbers or multiply them. You just kind of loop through the two vectors and add or multiply them individually, and then you kind of get a new vector with like a representation of the result.
Okay. Certainly a good way.
You could also use like a floating point number if you're doing Avogadro's number, because it won't. Yeah, you're not too concerned about losing some precision.
If you want to work with really big or small numbers, use floats, because floats are made to handle that well. In the PDF, I don't know if you read it at the beginning of the quarter, it talks about data representation.
Yeah.
And it mentions how floats would be good at handling that sort of thing, because they use scientific notation, sort of, which
float.
So it's not too hard to handle those.
I think time's up. You see the.
Yes. Hey guys, I really appreciate the past, 30, 40 minutes. Really appreciate it.
You felt like you learned a lot?
Yes,
from me
definitely.
as well.
Yes, I learned a lot from you, Chad, as well as other people too.
Yeah, this class is very fun.
Okay, Anand, come back. Summon Anand. Let me text.
Can I ask a question back about the switch statements again?
Oh, sure, ask away.
That's for Chad.
Yeah, will compilers optimize for switch statements? Like if you write, you write like a cascading like if, will the compiler be able to change that to a switch, or would you have to do that manually?
I need to research that, but I do know that some compilers do inline code that, when calling functions, sometimes without your knowledge, in case you're worried about performance, Many modern compilers you know, they figure out what's best to inline, you know. I said that on my Reddit post. You can look at it on why calling functions slows it down.
Yeah, I think I saw your post. Yeah, I was just curious about the switch case ones.
Yeah, hey, was that Ryan?
Yeah, that was me.
Oh, okay. Yeah, I just took a quick look. Good question though. Yeah, it looks like switch statements is probably more efficient than if statements, depending on, you know, especially like if you have like a chain of if else, if else, if else. Supposedly switch statements faster. So yeah, it's more efficient.
Yeah,
it's easier to read. It's easier to read too.
I looked it up. I think I remember a while back. I looked it up and found that, you know, the compiler seems to treat a if statement as like jump if or something, you know, like jump if this is not true or something.
And chat. So now if it's a switch statement, how is it different than an if statement?
I think it creates a jump table or something.
Ah, okay, very interesting. Okay.
If statements are definitely jumps in assembly.
Yep.
Yeah, in assembly, it's like, I think I saw a video on it. It's like jump if not true or something, if I'm correct.
Yeah.
Yes, probably something.
You know, if it's true, it'll just keep going. And so it kind of takes more time. And I know even modern compilers don't recognize that and turn it into a switch or something.
Modern compilers are pretty efficient. There's Clang and G++. I don't know the intricacies though, so I can contribute to that.
That's why I know that, you know, I said that in my Reddit post, how one example of how they are more efficient, you know, is they convert function calls into inline codes at times.
Yeah.
But that's great. I have a question, Matthew.
Yeah. Fire away.
So I remember seeing this YouTube channel a while ago called Matt KC.
That would not be me.
Oh, you kind of sound like him.
Oh, yeah, it's just a really common name, for better or worse. So.
Cool, good to know. I just thought you were that person.
No.
Because that would have been right.
That would have been fun.
Interesting. But you know that channel, right?
No. I don't really watch YouTube, so I do not.
Cool. Yeah. But can we call Nand? Let him know.
I just did.
Someone could try. We could try.
Because I do want him to ask why, you know, calling functions takes longer overhead.
Well, that was in your Reddit post, right? I don't know if that's relevant. But...
You know, but I just, you know, I think he wants to answer that as well.
Maybe.
But I think if I'm correct, jumping to another part of the code takes time technically for CPU, right?
Well, any operation takes time. You can measure it like they do.
I mean, like takes a bit more time than just like iterating, I think.
If it has to do a conditional check, then it takes longer than if it knows what it's going to do before it does it. Because a conditional check, it has to consider both possibilities that it can take. Whereas if it knows what's going to do, it just goes that way.
Cool.
And it's
so
much easier.
And I think accessing RAM takes a bit of time as well, right? That's what sometimes jumping has to do, right?
Well, not exactly. There's memory, there's like L1 cache, which is on the CPU. So it's not accessing. Yeah.
Yeah, I know there is some cache. I'm just saying, you know, for like, you know, the really big stuff, right?
Right.
Like, it may not be able to cache everything, right?
Yeah. You only
get has to store it in RAM as well, right?
Yeah, sometimes.
Yeah.
If you have a lot of stuff to store.
That's what I meant, you know, if your code is large, you know, it could definitely take time to access the RAM, right?
But optimizing is something that you'd worry about after you have working code and you know that you need it to run faster. Like if you have, if if you run a like camera application and it runs fast enough that it looks smooth, then like it might not matter to you if it goes faster or smoother because it's good enough. But
wow, nice car, Ben.
What I'm just trying to think about ways if I can, I don't know if it's even possible to make a program that draws for me, or on a very rudimentary level, and then I can draw on top of it, or like to feed it like millions of images, and maybe it can come up with something that a human can find intriguing and unique, aka like sourcing inspirations.
So someone about L1 cache. I noticed that CPUs only have 512 kilobytes. Modern CPUs.
Well, depends on the CPU. Yeah.
I mean, I'm saying most current modern ones do.
Yeah, somewhere in that ballpark. I don't really know. But they have a couple of caches. If, I don't know, it's not something I'd worry about until I'm optimizing. And so far, I haven't had to optimize my code because it's not production code. So,
but you still do know that technically RAM is the slowest, is technically.
Well, yeah, it's the slowest by far. You don't want to use it if you don't have to, but
you know, I think there's also L2, L3, which is slower, right? But not as slow as RAM.
Yeah.
And that's why I think it uses RAM for more space.
Yeah, it usually does it on its own. It decides where to cache stuff. But you can tell it explicitly you want to cache something in L1 if you know that you're going to use it, and it would help to have it in L1.
And I think my teacher, Anand, said that you don't necessarily need to optimize your code, right?
Well, yeah, like, unless you have to optimize your code.
Yeah, like, you know, if it's needless, you shouldn't do it, right? It's just a waste of because
it's up to you. Case by case basis.
I just remember, you know, he talked about this thing that was a profiler, which can help decide if you need to, right?
Mm-hmm.
Optimize it, right?
It's
and I'm sure when people make games, because there's a deadline, not all the code's optimized, right?
Probably not.
That's true for basically any product.
Yeah.
When you have a deadline, I mean, you can't spend forever trying to optimize your code. You kind of have to deal with what you have. I mean,
even if it's a little messy at times.
Yeah, programmers are notorious for complaining about other people's code because, you know, they likely created that code in a rush. They needed to get something out as quickly as possible, and as a result, that creates sometimes non-optimal code.
Yeah, but usually most people don't notice it. And, you know, that's why a profiler really helps with that sort of stuff, right?
A profiler tells you exactly what's happening. And
that's what I mean. You know, profiler tells you, you know, which parts of your code are taking up the most resources, right?
Yeah, that sort of thing. You can even see the CPU instructions, which are taking up more than you'd like. Because
sometimes code can be messy, but, you know, it's kind of, but, you know, it has very tiny impact, very negligible impact on the computer's performance that nobody notices it, right?
Yeah, sometimes. But it's also, well, there's a lot of things that go into like code quality, like comments can be an important part of code, just so it's more maintainable and easier to finish coding the project. Because if you know what's happening and other people can work on it, then comments can help. So lots of attributes.
Yeah, I think they even do that with deadline projects. They comment code, so you understand what's doing, Gray.
Yeah, it's probably like what's a really important part of coding in general.
And I saw debug symbols. You heard those? I saw that when I compiled my program. I think commercial coders usually try to remove it, right?
Oh yeah, what is it? There's stuff that would help you debug it.
Yeah, I think it kind of helps, you know, it helps, you know, the computer know which part of the source it's executing, right?
Yeah. What is it? There's one thing called, imply. I forget. I don't remember.
I'm noticing that when I run a Visual C++ debugger, it can pinpoint the exact line that it's running, and I think the debug symbols are what's causing it.
Yeah.
Right? Converting it back.
I'm not really sure. I haven't debugged my programs.
But yeah, I think I did hear that when you're a commercial coder, one of your biggest responsibilities is to remove these. Otherwise, people could decompile your program, and you know what could happen, right?
Well, it's
like strip the debugs.
Yeah, case by case basis. You might not care if people decompile your program.
Yeah, I just mean a lot of companies do, like if it's proprietary.
Yeah, they might. But that might be something that's done in the build process, because that should be automated.
Cool. Yeah, but I do know some game developers actually don't care if you decompile their programs.
Mm-hmm. Makes sense.
I know, like the Minecraft peer doesn't care if you're just simply looking at it.
Mm-hmm.
You know, that's why Minecraft mods exist.
Yeah, I haven't read too much about that. People don't like the modding community too much on Minecraft, or the way that they do mods, because you have to update the mod like every couple of years when they come out with a new version.
I feel frustrating. Yeah, I feel like that's why I just like vanilla better, or server plugins.
Mm-hmm. But it's the same way with those, I think. I'm not sure. I haven't looked into it too much. But you have to update all that stuff once in a while, because they don't offer a stable API to their the mods and plugins, which is unfortunate.
Cool. Yeah, that's one thing about, because code can really change a lot with every update, so that's why they have to be updated, right? The code can change in certain places, right?
Yeah. If you're not careful, you can break things that depend on the code, which in this case would be plugins and whatnot, because they depend on Minecraft, because, well, it's built on top of Minecraft. Yeah. They didn't build it, well, what was it? I don't think they built it with plugins in mind. They were just trying to make the base game, and they didn't really make room for those sort of expansions. So it's a little bit messy in that regard.
Cool.
Hey guys. All right. Well, did you guys have a good time? Was it useful? Was it useful?
Yeah, it was very useful.
Great.
Some people like Ben learned a lot.
Yeah, okay. Yeah, because looping and branching, those are your bread and butter. And the more you can do to get comfortable with that, the better. In fact, it's better to even overcorrect and be over comfortable with looping and branching. Yeah, it's almost got to be part of you, so you can use it unthinkingly. That's really the goal. All right. Yeah, that's great. So if you guys have any questions about any of the stuff that you did when I'm not there, or if you have questions about other things, related things too, that's fine. We can leave stacks until next week. Not next week, until Thursday. We got the rest of this class. We can basically.
I finished stacks. I finished the stacks quest, so. And I have a question.
No, not about the stacks quest. You can't ask me about the stacks quest and all.
No, I'm not saying it's not a question about that.
Oh,
it's
all
about,
right, okay.
Remember you said you were going to answer that question, why calling a function takes longer than, using it inline to function, like a macro.
Yeah, I thought you already answered that in the Reddit.
Oh, never mind.
Yeah. I
just want to make sure it's correct.
When the class started, I said that was a really cool post. Didn't I say that? Or am I just imagining things?
Oh, I'm not sure.
Yeah, I think when the class started, I said, hey, Chad, that was a really cool post.
Yeah.
Yeah. All right. Okay. So yeah, I saw that. That was cool. Yeah. But we shouldn't trust. We shouldn't do all these micro optimizations, like you said. The compiler will take care of these things. Because it's not even just it's many times some of the modern compilers know what loops to unfurl and what loops to not unfurl, right? Because they have not only on the same machine, the same code on the same code and the same compiler will compile differently into machines. Maybe on an Intel machine, it will be unfurled, right? The for loop will become 4 blocks of actual code, where on another machine, it may actually remain a for loop, right? So because the compilers can do lots of intelligent things now. It can even, simulate things and find out if this is faster than that, we'll do it this way, and so on and so forth. All crazy things like this, right? So we don't have to worry. So in fact, that's why, just like neural nets, like deep nets, after a while, so you just train it on input and output data, and you say, well, is it giving me the desired output or not? Right? If it's giving me the desired output, no matter how much I try to fool it, right? That's the most important thing. You got to try and break the system in as many creative ways as you can think of, right? To feed it wrong inputs, feed it a dog, and is it saying it's a cat, right? All kinds of crazy things. Break. Eventually, you say, well, I've tried every damn thing with this black box, and in every case, it's producing the output that I want, right? Not incorrect output. Then you say it's fully trained, right? Because it's not been overtrained, it's not overfitting corner cases and all these things. It's been trained and tuned. And I don't know where we're going with that, but like that,
As long as it works, it's good, I think, is where you might have been going. You don't need to worry about how fast it is. You were talking about how you don't need to worry about optimizations as long as it works.
Yeah. Thanks. Yeah. We just trust the compiler to take care of these things, because after a while, as a programmer, we can't afford it. So we don't have the time to think about because the field of compiling has gone so deep that we don't have the time to dive deeply enough into that field if we want to also simultaneously have a significant amount of mental cycles to focus on what we want to do, right? We want to build a house, but we don't want to go and learn about how bricks are made. It's just like that. So we got to learn to trust the compiler to say, all right, you do these things, but after I've done everything, I'll just run it and say, if it's fast enough for me, okay, I'll leave it alone. If it's not fast enough for me, then I'll profile it and find out, where it's spending a lot of time, right? Because if you have a company that is not doing the right thing, right, and you're the CEO, right, and you have a company that is dysfunctional and it's not producing, has lots of losses in the company, then you don't want to reorg the whole company, right? So you want to run some tests or some analysis to find out which parts of the company are draining the whole system, right? And then you go and find out, well, you're not going to, fire the entire team, but you're going to say, well, in that department, what's going on, right? Why is that department having a tough time when everybody else is doing such a great job? So there's something that is making you guys unhappy, right? So let's try and figure out what that is, and then do these things. That's profiling. Right, because if you just buy a brand new CEO of CEO Depot, right? So you go to CEO Depot and buy a brand new CEO just out of MBA school and say, all right, you're going to be the CEO of this multinational company, and this company is not performing to scratch. You got to go and figure out what the hell is going on. It's like a brand new programmer, right? He's a brand new programmer given a Google code base or something like that, and say, oh, figure out why these searches aren't working, right? So maybe just a regular expression wrong somewhere, right? So which you may find out very easily doing some quick tests. But this guy has no experience. I'll say, well, okay, today what we're going to do is scrap the entire Google code base. We'll start from scratch because I have this idea of how to do these things, and I'm pretty sure there's lots of bugs in there, right? You're going to toss everything. Well, I won't trust these people to do their job, so I'm going to do it exactly the way that I think that should be done, right? So it's not the way to do it. And likewise, I think profiling is when you have a big program and then you find out it's not doing as efficiently as you want, things as efficiently as you want, then you profile it just to find out specifically where, right? It's like treating antibiotics, which will basically nuke all of the flora, fauna in your body, right? Along with the good guys and bad guys, everybody goes, right? Then you have to replace your good guys with yogurt and all these whatever, right?
Is that true that antibiotics are usually targeted towards the
I don't know. I just follow what the doctor says through years and years of learning experience. But I think I have found in the past that when I've had when I was much younger, when I've had heavy duty antibiotics, I always used to have stomach upsets too, right? And then it takes a while for that to go away. So maybe it's just a side effect. I don't know. I'm just, this is a hypothesis, right? Like I told you before, I don't know, maybe if I made this point in the very first class, everything I say has a chance of being wrong or right, okay? So you have no idea if what I say is true or false. How is that having me for a teacher, okay? The teacher is supposed to tell you right things, right? So here I am, I'm your teacher. I'm going to tell you both right and wrong things, right? Because my goal at the end of the day is not to fill you up with lots and lots of right things and send you out the door. You know, what the hell? You know, it doesn't accomplish anything for me, right? Rather, I don't want to fill you up with anything at all, but rather, I just want to sharpen your apparatus to tell what is right and what is wrong, right? So that I don't have to do the hard job of filling you up with all the right things. You can do it yourself because you now know what is right and what is wrong. You can just fill it up yourself, right? So like that. Yeah, I don't know how we got talking about that, but yeah, so certainly like that. I think if once we start trusting the computer to do its thing, yeah, I don't know. Anyway, so that's where we're going with this, and it's okay for this entire class. I don't care if this entire class was taken out, just reviewing past material, right? And also, by the way, you know, it's week 12. Week 12, technically, or officially anyway, is not supposed to be lecture week, meaning that lecturers, are not supposed to teach you new material. Oh, that's my interpretation anyway, right? I might be wrong, but I'm not going to go and check until someone corrects me, right? From admin, right? I'm going to assume that I'm allowed to have lectures, but not introduce new material, because ideally I can have review classes, right? Some of you like tutors. I can have like tutors. So week 12 also. But I don't know. Maybe I won't do it this year, unless enough of you want it, right? Because last quarter, I said we'll do classes on week 12 too. If you guys are struggling with something, we can go over review stuff. And I think one person turned up for a week 12 class, and it was almost like a one-on-one. And I don't even know how much value was transferred during that class. So we won't do week 12 lectures unless you guys desperately want to have a class of more than at least 2 or 3 people, right? So get together and get in touch with me. I'm happy to do classes in week 12 also, both Tuesday and Thursday. That's fine with me, right? I just need to, I need some time to fiddle with the LOCEF notes, because we've been notified by the admin staff at Foothill that the FGA media server is going to go away in April. And all of my LOCEF reference material currently stored on FGA media. And of course I have a mirror. And also, honestly, I think that the stuff that I got is like, 3 or 4 years old from, Michael, when he retired. I just took a copy of 4, and then I made some minor mods. But he's imagine this, right? He's completely retired from Foothill, but he still maintains an up-to-date copy of all of the LOCEF notes on locef.org. He still maintains it, even though nobody's paying him for these things, right? And he's doing this out of a sense of goodwill for our students, the computer science community generally. And I still think, right? I've just, the reps give us so many books, right? Review this. And I'm yet to find a text that so succinctly captures what is core to be taught to beginning classes in C++, or even intermediate and advanced, by cherry picking all the right topics, right? Because in a textbook, it's really hard, right? If you give me the Savage textbook and say, well, you got a CS2A exam in 2 weeks or 2 months, right? Honestly, it's impossible for me to, I have a mental block against skimming through this book to prepare for an exam. Right. So what I want is someone who's actually read through the book and said, well, this book has a lot of interesting information, but 90% of it is just reference. Right? You take any book, right? Most books, 90% of the book is just reference. And only 10% of the book is actually telling you what to do. Right? So only 10% of the Savage book is basically telling you the guts of C++, like, right? So it's loops and this is how these things work. The rest of it is example code, variations, all these things, which you should not read right? In the first reading, you should be on your shelf. Then later on, when you're trying to code and you want to do a complicated construct, and you say, well, that's a for loop, but I want to do a different kind of for loop. Well, is there a different way I can do it? Well, obviously you can go to Google, and when you go to Google and do this, you're going to get like a ton of hits, and some people that don't even know what they're talking about, they're going to be, and they have all their friends voting it up, and so unless it's Wikipedia or some trustable source, so then you can go to your reference book, right? And say, well, all right, now I want to look at page number 245 where, a whole section on for loops, okay? Because previously when you did CS2A, you don't need to read the 15 pages on for loops, and the 2 pages on for loops gives you a rough idea of what it's doing, right? This is doing in a loop, right? One out front of it. So, and keeping track of where you are, right? This is the first time through, second time through. So, and so 90% of any text that you pick up for any subject, right? Even if you go on to do masters or PhDs or whatever it is, 90% of the books or materials that you buy is just reference. After you already know what you're looking for, that can be a reference to go and find out specific details. But the problem I find with lots of people who basically just give up a field as soon as they enter is they look at a thick book and say, wow, that book I got a master in order to pass this course. That course is not for me. I'm not going to do it, right? That is so silly. And that is why I actually discourage people from going and buying books, right? Because don't do that. Because if you look at that book, it's very intimidating. You're going to give up C++, right? The truth is that you don't need to master that book. You need to master probably, 50 pages max, right? 50 pages, that much. And easy, very easy, and practice, and not all possible variations of for loops. 1 or 2 just to give you an idea of what to do when you want to accomplish a big task and you want to loop in there, right? And then at some point you'll discover, for loops, okay, I want to try a different thing which is slightly better, right? Then you can go and look. And so, and I think what Losif Michael did was quite incredible, right? Better than any other distillation I've found out there, because you go Google out there and you find notes from all these colleges everywhere, right? And then you ultimately say, well, I'm going to use this, and I still haven't found a collection of material that have basically cherry picked exactly the right topics, right? Sometimes you can go off more, and that's the beauty. That's why I like Michael's notes, and I kept them there, is because it's basically 2 topics near each other. And which one do I choose? Because I only have 24 classes, and there's 2 topics I need to teach. Which one do I teach, right? That itself is a computational problem. Think about it, right? So you got to put yourself in the student's shoes and think about, well, both of those topics are important. For a student, which one is more important than the other? Can I quantify it? How many algorithms use this concept? How many algorithms use that concept? How likely is this going to be used in real life, right? All those things play in and say, okay, well, that is a topic I'm going to include in my modules. So Michael has done that much work to put these modules together, and they live currently on FTA Media. They're going to go away. So, and I took a snapshot like 5 years ago, and he's still maintaining that that's what I say, right? So, and you guys have, maybe not you guys, if you're going to go do my 2B, 2C, you got to go and find out where Michael's notes are. They're free, 100% free, right? Incredible, isn't it? 100% free. They're, you got to find out where they are. Maybe there's definitely at losif.org, right? Or you just email someone at losif.org saying, hey, Michael, where are the notes? I'd like to refer to it. I'm pretty sure you'll get a link, right? See, the CS Club is probably going to put together a link. So there's another place you can find it. But I think those are the best possible notes you can ever have, not on your virtual bookshelf, because you can actually go to specific things that you want to know, and they're a great distillation. So, what was I going with all that? So so because FGA Media is going away, I want to take about a couple of days to basically migrate my copy of his modules to somewhere else. Maybe I'll put it on nonlinear media, right? So somewhere there, so that you can refer to it. But I also want to put a disclaimer saying that these are like 4 years old or 3 years old. You can find the most recent version of these notes at losif.org or something like that, right? So you can go there and find the most recent version. But the C++ is not like changing every day, right? It's 5 years old. It's pretty much 99% is pretty much the same. So you can still use these notes, but he still maintains, right? He makes some minor tweaks here and there, changes assignments, and so on and so forth. So totally check it out, and I'll make sure it's all there. But other than that, I'm free, right? So week 12, and then we got 1 week of spring break. Yeah, maybe that's when I'll migrate all these notes. But I still have to do the syllabus for spring, so I'll do the syllabus maybe in a couple of weeks, maybe next week. Right? It's a spring syllabus for 2B and 2C. The 2A and 2C. I'm not doing 2B in spring. Okay, 2A and 2C. I'll do the syllabus. Which means, unfortunately, I may not be seeing most of you guys next quarter, right? Because I'm not doing 2B. I say, you are obviously, you're welcome to continue questing. You do my 2B questing, you don't have to be a student, right? Just do the 2B questing and also enroll in someone else's 2B section, right? So I actually, someone asked me and I said, that's the best thing, right? So in fact, that's really cool because here's the way you can do it, right? So you can enroll in someone else's 2B section. What time is it? 9:46. Oh, I got 4 minutes, right? So someone enroll in someone else's section, 2B section. How many dollars is it? Like $200, $170, right? $170, right? $170. Enroll in someone else's section and pay your fees. Right? So you get their notes, their classes, their lectures, you get to ask them questions, you get their tutors, everything, right? And simultaneously, you can, in your own free time, participate in the 2B green level questing, right? Do the green quest and participate in the green forum. And at the end of the quarter, people can nominate you as the most helpful member of the green forum, even though you're not officially a student, right? Even though you're not a student, someone can nominate you saying, hey, and then you get a $250 prize, right? For being the most helpful member in the green quest, right? You get $250 from here for not even enrolling in the class, of which $170 go to the fees for the other 2B instructors class. You still end up with $80 in your pocket. How cool is that, right? Okay, so that's an idea for you. So yeah. So try those things, and certainly, yeah. We can talk about stacks. We can implement stacks next class. What do we need for stacks? We just need a little bit of pointer knowledge because we're going to do it with pointers. And do we need loops? Yeah, we don't even need loops. We don't need loops. All right, we'll come up with a situation where we actually need loops, right? So maybe we'll come up with a situation where we actually loops, but we certainly need branching statements, right? So branching statements, loops, and pointers. Those are the only three concepts you need for next class when we implement a stack using allocated nodes on the heap, right? Not on the stack, it'll be on the heap. Right? If it's on the stack, slightly faster. Again, like I said before, no, we shouldn't be optimizing these things. Sometimes we can help the compiler. Okay, sometimes we can help the compiler, like in Fibonacci. In Fibonacci, for example, if you have these two variables, this is actually maybe important, right? Someone should probably check this, cross-check it, and tell me if I'm right or wrong, right? So you have these two variables, and now suppose you do a new for these two variables. You get two long integers on the heap, right? We haven't even talked about pointers, right? So let's suppose you have these two pointers in the heap, and then you're using those two integers in your loop. The compiler does not have that much scope, all right? I don't know. It need to have an extra level of intelligence built in to optimize that. By optimizing, what I mean is that if those two integers were on the stack, right, in a different area, or just even automatic variables, right, or basically in a stack, right? So then the compiler could say, well, those two memory locations on the stack, I'll just turn those two memory variables into register variables, right? So anything in the register is blindingly fast, right? It's right on the chip itself, not in a different chip that you have to get on a bus, right? And travel on a bus to get it from the memory chip to your CPU, right? That's really slow. If it's in RAM, it's slower than if it's on the CPU, the register itself. So I think if it's a regular automatic variable, you can tell the compiler that it's okay to optimize that into a register. But I think if you explicitly went out of your way to do the unintuitive thing, right? That's what it is. That's the reason why it's not optimized, right? Because allocating those two variables on the heap using new, and then when you're done with those variables using delete to delete, remove those variables, that is unintuitive and not the C++ way of doing things. You know, every time you want a variable, you don't allocate it on the heap. You just allocate it on the stack, you know, locally. So if you do it on the heap, then C++ compilers are not designed to accommodate for these corner case programmers who do some really weird ass, you know, crazy things that are not usually done by intelligent, you know, brilliant people. They're allocating things on the heap, just two variables. So those things, the compiler will say, well, you know, normally these two variables would be on the stack, so I can put them into the register. But in this case, the programmer probably had a reason to put them on a heap in that particular location, right? So because the programmer did it in that weird way, they probably have a really, really clever reason for doing that. I'm not going to mess with that and try and optimize that and break their code, right? So in that case, the compiler is actually trained to leave your code alone. So in fact, even if the compiler wants to optimize your code, you're telling the compiler, don't optimize it because I'm doing it in a crazy ass way, right? And so that's why if you do it in the non-conventional way, compilers have a much harder time to make your code run faster. I don't know if that was useful. And I don't even know if what I just said was correct. All right. So obviously, you should feel free to check with experts in computer science or in compiler theory,
So,
or things. And
I think I did talk about while you were gone, why you know how some coders have deadlines in their job. Many do.
Yeah, absolutely.
And you know, a lot of times the code isn't fully optimized. They just optimize the parts if it's like really slowing it down or something.
Yeah, totally. No, absolutely. Yeah.
So
many times coders are working under extreme pressure.
I was looking up the stack file structure, the stack organization for CPUs.
Mm-hmm.
Is it like, you know, what we just did? And
yeah, it's very similar. There's a stack. The idea of a stack is very, very simple. You know, that's why
it's just, you know, like what's next in execution and all that.
Yeah, all of that, the chain, you know, it's an entire frame. It's called a stack frame. It stores a lot of information, the parameters for the function. More importantly, it stores the return address, you know, where to go after done, right? So
that's very simple.
Yeah, we run out of time today. But we'll absolutely talk about this next class, because next class we're supposed to be implementing a stack, right? So while we're implementing a stack, we'll talk about all these side issues, how a stack is used by the CPU and things like that. Yeah.
Cool. Yeah. Thanks. Maybe during my free time I'll find a computer expert that can explain it.
No, we just wait until next class. It'll be pretty straightforward, right? So
it is very straightforward. You think you have the right idea on what it does.
Yeah. All right. So we'll talk about all of this next class. But as far as what I said about the compiler, you have to do a little bit of research, right? Find out how the compiler optimizes code, and what I said before, that, you know, if I have two variables on the heap, will the compiler optimize that onto registers or not? Well, assuming that those two variables are in fact, if they were not on the heap, they would be made register variables, right? That means the compiler actually optimized them, right? So I just made an assertion saying that if they were not automatic variables, but they were on the heap, the compiler will not optimize that for you, right? So that's an assertion. It's I don't know. It could be completely wrong. So that's something that you can find out.
Got it.
You can find out very easily. Yeah, you don't even have to ask someone that's deep in compiler theory. You can actually just Google or look up some literature on compilers and find out the answer if you want, if you're interested.
Cool. And also the stack, I think, is faster than RAM, right? The CPU stack.
I mean, L1 cache is faster than RAM. I think that's what he's asking. Yeah.
No, I'm talking about stack.
I don't know. The stack is also on RAM. The stack is also part of the memory, right? It's not on your register. It's not on the CPU. So
I know registers are faster than RAM, right?
Registers, obviously, it's faster, right? So anytime you need to go to the RAM, you have to get on a bus, right? So the bus connects the memory to the CPU, the chip, right?
Yeah, I know that.
Yeah. So anytime you need to get on the bus, it's slower. But anything on the CPU chip itself is fast. So registers, I don't know, lots of registers on the CPU. So that's fast. I don't know if stack is faster than regular RAM, but that's something you can find out easily, right?
Cool. Okay, I'll just do that.
Where they are, yeah.
So I'll see you later.
Yeah,
I gotta go have breakfast. So.
All right. So was this a useful class? You know, although I was absent most of class today, I was purposely absent, right? It's not like I wanted to ditch you guys, but I want you guys to, you know, feel more comfortable without me, because I have a feeling that I'm kind of cramping your style.
It's extremely useful, and I was able to help someone in need.
Great. All right. Share your experiences, and we can obviously have more of this, right? We have 4 more classes. Week 11. No, 3 more classes, right? So we can absolutely have more of this if you want. Okay. All right. Then thank you so much for coming by, and most of you are attending every single class. That's absolutely fantastic. So I'll see you guys on Thursday, okay? And we'll actually implement a stack on Thursday. Well, I hope you get to implement a stack. All right. Okay. Thank you so much.
Thank you, Professor.
Thank you.
Thanks.
Thank you.
Bye.
Bye.